Sketch the graph of y equals 2 to the x minus 3. This is an exponential function. We know that the graph of y equals 2 to the x minus 3 transform the graph of y equals 2 to the x by shifting the graph of f of x equals 2 to the x down 3 units. And so if we have the graph of 2 to the x, we simply copy it down 3 units. Alternatively, we can make a table of x, y values and plot the points and then sketch the graph. Usually we make a table with 2 columns, x column on the left and the y columns on the right. The domain of an exponential function is the set of all real numbers, so we can use any numbers. Usually, we use number around 0. 0, 1, 2, 3, 4, or negative 1, negative 2, negative 3. We usually write the numbers in increasing order because on the coordinate axis, the x values go from the left to the right. When we plug in 0, 2 to the 0 power minus 3 is 1 minus 3 or negative 2. This gives us an ordered pair. This is 0 comma negative 2. So we would plot x equals 0, y equals negative 2. Similarly, if we plugged in 1, 2 to the 1 minus 3 is 2 minus 3 or negative 1. 2 to the 2 minus 3 is 4 minus 3, which is 1. 2 cubed minus 3 is 8 minus 3. 2 cubed is 2 times 2 times 2, which is 8 minus 3 is 5. And when we plug 4 into the equation, this is 2 to the 4th minus 3. 2 to the 4th is 16. 16 minus 3 is 13. Similarly, we plug in negative 1 to the function. 2 to the negative 1 minus 3 is 2 to the negative 1 is the reciprocal 1 over 2. 1 over 2 minus 3 is negative 2.5. And then negative 2 plugged into x, 2 to the negative 2 minus 3 is 1 over 2 squared minus 3. And so this is 1/4 minus 3. A quarter minus 3 is negative 2.75. And so on. Each of these ordered pairs will give us a point on the coordinate axis. When x equals 0, y equals negative 2, we plot it already. When x equals 1, y equals negative 1. When x equals 2, y equals 1. When x equals 3, y equals 5. This is easier on the graph paper. And when x equals 4, y equals 13, we're going to omit that order pair because we would need to go all the way up. When x equals negative 1, y equals negative 2.5. Be careful with the decimal numbers. When x equals negative 2, y equals negative 2.75, which is not negative 3 yet. In fact, the graph will never go below negative 3. We know this because 2 to the x is always positive, and any positive minus 3 will not be below negative 3. Knowing that the graph cannot go below negative 3 and it is increasing, we then connect these points to form a smooth curve. This is the graph of an exponential function y equals 2 to the x minus 3. And again, if we were to have the graph of y equal 2 to the x, we will see that this graph shifts the graph of y equal 2 to the x down 3 units. The domain of this function is the set of all real numbers. Any x will do. The range of this function is from negative 3, it had to be greater than negative 3, to infinity.